we're going to graph equations by using the intercepts. There's a bunch of different ways you can do this, but we're going to do it this way for example 6. So to find the x-intercept, remember the x-intercept is y is 0. So in my equation, I'm going to replace y with 0. So I get 4x minus 0 equals 4. I don't know why I wrote y when I meant 0. Let me try that again. Minus 0. Well, 4x minus 0 is 4x. Divide both sides by 4. X is 1. Is an ordered pair. That'll be 1, comma 0. So on my graph, I'm going to put a point at 1, 0. You might notice that, did I really need to write that first equation? Could I have just gone straight to the second equation? Sure, you can. I'm going to always do it by showing the substitution, but you can do it that way if you understand what's going on. So to find the y-intercept, we're going to make x 0. So I'm going to have 4 times 0 minus y equals 4. 4 times 0 is 0. 0 minus y is negative y. So I divide both sides by negative 1 to get y by itself. So y is negative 1, so we have, negative 4. Let's try that. Sorry about that. 0, comma, negative 4. So I'm going to put a point at negative 4. Now I've got my 2 points. And now I can graph them. I'll draw a line going through both my points. Didn't do a very good job of drawing that line. Let me try that again. There we go. Use a ruler. Now in example 7, I'm going to do the same thing. Except I think in example 7, I'm not going to use my intercepts. You can do it a whole bunch of different ways, but just so we can see what's going on here. So what I'm going to do is I want to make a table. You can always make a table to graph anything. And I'm going to go from negative 3 to positive 3. So I'm going to replace x with negative 3. So I go 2 times negative 3, that's negative 6, plus 2 is negative 8. Try that again. Negative 6 plus 2 is negative 4. Let's try the second one. 2 times negative 2 is negative 4, plus 2 is negative 2. Let's do 0, or negative 1. Negative 2 times negative 1 is negative 2, plus 2, that part is 0. Nice things happen at 0. 2 times 0 is 0, plus 2 is 2. Let's try 1. 2 times 1 is 2, plus 2 is 4. Let's try 2. 2 times 2 is 4, plus 2 is 6. 2 times 3 is 6, plus 2 is 8. Do you see how they go up by 2 every single time? That's what makes it linear. So let's graph these points. So negative 3, negative 4. Negative 2, negative 2. Negative 1 and 0. 0 and 2. 1 and 4. And I kind of ran out of room on this graph, so I'm just going to plot. I'll stop there. I'll draw a line going through those points. Now, I could put anything in the world in for x. X is your domain. So the domain of this function, I'm going to say, is all real numbers. You might see it written as from negative infinity is less than or equal to x to positive infinity. That's the same thing. A range is the same thing. I can find, no matter what I do, there is a value of y that's going to be on this graph at some point. So this one is also all real numbers. Or negative infinity, if you want to write it as an inequality, is less than or equal to y, which is less than or equal to positive infinity. Actually, I'm going to take off those equal signs because you can never get to negative, you can never get to infinity. You can get close, but you'll never get there. So we're just going to write it that way. So you can write either way. You don't have to write it both like I did. You can write it as an inequality, or you can write it out in words.